We've hit the top of the hour. I'm going to wait a minute or two for any stragglers to join, and then we'll get started. Okay, that's good. We got a couple more attendees, so let's go ahead and get started now. Welcome to the CBOR call, the last one before the IETF 125 meeting. Lawrence, over to you.
Do you have the slides?
I will give you slide management. There we go. I always forget about that bit, and I have to do that.
Okay. No problem. We got it. All right. So our usual topic of serialization. So draft 04 was published. It renamed from ordinary to preferred plus. I want to discuss that a little bit later. I removed the appendix. It was Appendix C. It was the thing that defined deterministic serializations for common tags, serializations for like the date tag and stuff like that. I think there was agreement that was fine to remove it. The introduction was expanded quite a bit to include some rationale for why we're doing this. That's something else I'd like to talk about a bit today, and that is kind of a response to some of the discussion on the list and to some of Karsten's comments from last interim, and I think a useful thing. The control operators are all renamed. Pref P to align with preferred plus, and since .det was taken already, I just chose .dtrm for deterministic. If we want to change those, that's okay. I just made a decision and went with it. I'm not, but happy to have other suggestions if we want to like do something else for deterministic. And then there was lots of wording improvements, and that was much of which, I managed to process all of Rohan's review from a few months back. There was too many merge conflicts and other things I didn't agree with in Rohan's review that I couldn't just, merge the review. So I just went and made 3 other separate PRs and merged them. So that's the 04 draft. There are 5 open issues. Some of them are waiting for more writing to be done. So Rohan requested security considerations. I requested him to write them, so we don't have that yet. There's just a little bit of improvement that I want to make to the COSE example appendix. Nothing, it's just wording. There's a couple of to-dos in there and stuff. Then there was, I rearranged the issues a bit now that we removed Appendix C. And there's Appendix B, which Rohan had suggested be moved to the main body of the, that's the appendix on how to do determinism at the data model level, also known as ALDR. I don't have any comments on that today. Then another possibility is to move the appendix on nouns, it's like 5 pages of explanation on nouns, to move it elsewhere. I don't have any, I mean, that seems like a possibility. The whole document's like 34 pages in strict text format, and 5 pages of that is nan appendix. So it might be a good thing to move it. And then examples and test vectors, that's an open issue, and that's, I think, where the bulk of the work to be done is, and that's on the list for discussion today. So let me stop there for comments or questions on any of these. Michael asks if Nan is going to another document. I think so, but I'm not like committed yet, and I don't know what other document.
And
Okay.
remember, partially referring to Michael's question, in general, when we're pulling out the appendices, the idea isn't to lose the information. It's going to go somewhere, another document, a wiki, something. It's just that the idea is removing clutter from this document, that we can just say, if you're looking for this, go over, look at it there.
Yeah, I definitely don't want to lose that. I mean, it was a lot of work, and it took even more work in the long discussion to actually get to all of that information. Okay, so we've got a few votes for separate drafts, and Vadim wants it to keep it. Okay, I'm just gonna move on for now, and maybe I'll post something to the list or something, but I don't think it's a big deal either way. Okay. All right, so I just wanted to check in. I mean, there was some support for Preferred Plus. So I went ahead and made the change. I really like it. I think it really conveys what we're trying to do here. But I just wanted to see if anybody had any other comments on it. Also, the other thing, I went and changed my CBOR library to use that term, and I found that change to be very low impact and it was very easy change to make, and I really liked how that turned out as well.
I've got no issue with Preferred Plus. It seems fine.
Thanks, Joe. Okay. All right. So the new introduction then. We're moving along well. So I'm going to okay. Oh, Karsten?
Yeah, one problem I had when I looked at the introduction section, this has a similar sentence to what the first bullet item on your slide is. And I think that's a mischaracterization. And that's maybe an indication of the big cleanup that we still have ahead of us here. So if you use CBOR wrong, you can get non-interoperable serialization. So far, I completely agree. But what we designed in was support for partial implementation. And I have a couple of slides that I submitted to this meeting that explains that, but maybe we won't get to it today. We might get to it in Shenzhen. I don't know, but we have to clean this up a little bit because much of the motivation of the document is based on some feeling here that I cannot really quite nail down. So I think we really have to clarify this.
Yeah, I mean that's I think that's the big discussion for today, and I agree. We want to clarify this. So let's keep going. So the reason I say this, I mean I'm not saying CBOR was designed to be non-interoperable. I'm saying maybe I should say it differently, but CBOR's design is such that you could make a lot of choices that are not interoperable. You can choose. And particularly in the serialization, there's lots of choices there that you can make that are not interoperable, and two different implementers and two different protocol designers, that are operating on opposite sides of the globe that don't talk to each other can make decisions that are perfectly valid, good decisions, and end up with a protocol that doesn't interoperate. One chooses definite lengths and the other chooses indefinite lengths. That's definitely the case, and the design was intentional that way to allow work in constrained environments. And that's kind of why we're here talking about serialization. And partial decoders are common and they are allowed. It's just that's just the way it is. So I'm going to stop talking now, Karsten.
Yeah, basically, this is the question of whether you should allow 7.00 in JSON. And yes, you can make the decision that a decoder doesn't allow that because that second zero is superfluous, but no JSON implementation does this. And I think we need to get back on track to the situation where we have been with CBOR for the last 12 years, where essentially the summary of all people who have worked with it said, I'm not aware of any big interoperability problems. And those come in when we make decisions that actually get in the way of interoperability. We just shouldn't make those decisions. And as I said, I have a couple of slides that explains what I mean by that. But saying that the sentences that read like CBOR has been designed to be non-interoperable unless you are really smart in using them, that's nonsense.
It's not my intent to say that. Joe?
So I think if we anchor this thought in Karsten's wording here of partial implementation, then the value judgment part of this doesn't read as harshly. So I think if you say CBOR is interoperable between full implementations, however, when desiring partial implementations, for example, in constrained devices, care must be taken in order to. And then I think we can end up with some wording that works for everybody.
Yeah, sounds good. Yeah, I'm sorry if the wording came out that way. It wasn't my intent. I was just trying to.
Yeah, I read it that way too. So I'm just, I decided to take my reaction, filter it through. What can we do?
Yeah,
Um,
yeah.
yeah. So I think that just focusing on that partial implementation because of constrained devices means that you have to be careful when doing those partial implementations or designing protocols for those situations.
Yeah. Okay. Um, yeah,
So,
go ahead.
yeah, go ahead, Carson.
Yeah, so I think that the actual service that this document could provide to the community is identify a very, very small set of partial implementations that we actually endorse and that probably need some reflection on the side of the protocol developers, whether they want to license these partial implementations or not. And that is really the useful effect that this document can have.
I didn't understand that.
So what CBOR right now does is it says there might be partial implementations, but it doesn't really help with identifying the ones that are innocuous and the ones that are bad. So if you have a partial implementation that only does indefinite length for arrays, you will not talk to a lot of people. So I think we should identify those partial implementations that actually have a partial seal of approval and make sure that protocol definitions can reference these licenses for partial implementation using a short term instead of trying to restate and redefine the thing each time they need it. So right now, for instance, href has such a statement, that the CRI document of core working group. And we arrived at that after extensive discussion. And I think it would be nice if we could, for future documents, not for this one, this is done, just point to the serialization draft and talk about partial implementation 1, 2, and possibly 3.
Okay. Joe, do you want to? You're in the queue.
Oops, sorry. I just said the same thing on the chat, which
Yeah.
is I like this idea of endorsing some places where it makes sense for a protocol designer to allow for partial implementation. Having that be one of the goals of this document seems to align very well with serialization, to me, anyway, because they're in similar parts of the way I think about the code. And because of that, no floats is one of the constraints that seems reasonable for a very constrained device, particularly because a lot of the protocols that they're going to be using are just integers and strings. And so adding that into our repertoire might be interesting.
So there's a really big. To me, there's a big difference, or there are. So I'll say there are. Serialization is orthogonal to which data types you support. So partial implementation is because of two causes. One, because you don't support some serializations, and the other is because you don't support some data types. And this document is neutral so far about data types, whether you support them or not. It's neutral. It's not trying to profile data types or anything like that. It's very careful to use wording that says, if you support floats, then you do it this way. If you support arrays, then you do it this way. So that was the tactic taken. And the point of taking it that way is that the data types thing is driven more by the protocol that you're implementing, and what the library thinks you want to do. So that's the that's the approach taken. Yeah, I see the comments there, and yes, there is the NAND thing. We also have some straying into the data model thing with with big numbers as well. But to me, the NAND thing is not that significant at all, because NAND and NAND payloads are so uncommon and so unusual, and we want to keep them that way. So I guess let me ask the question is, if we are going to start profiling data types, what's the proposal?
I don't think we have to profile data types, but we can still say something like a common partial implementation in constrained environments is to leave out floating point.
But whatever we do there, it's orthogonal to serialization.
Yes.
We have to still,
Like the whole NAND thing, but it's the document gains if we properly partition this between serialization decisions and data model decisions. So I completely agree with it. On the other hand, talking about partial implementations might be a good reason to also point out maybe a non-normative statement. I don't know how to structure this here. That there are very reasonable considerations with restricting the data model as well. And I think no float is the one implementation decision that we have seen a lot.
yeah, okay.
If
Joe?
we had a section about partial implementations and talked about the data model there, that would be a good place to put the NAND bits so that it addressed Carson's valid concern that it's not a serialization constraint.
Yeah, okay. This is starting to make sense to me. What about anything else other than float?
I can go and look at if you give me just a second, I'll go and look at my options and see what else I've got.
So, Karsten, would this be a sensible point to quickly interject your slides? Or not?
No, I think we are further ahead than the slides are.
Good. That's what I was hoping.
I mean, the other thing on my list would be map keys that aren't strings or integers.
Yes. Something about, well, I mean, it's obvious that you don't have to support big ints, but you may as well put that in there.
Yeah.
I've got some bits about flushing subnormal numbers to 0 because somebody wanted that.
Okay.
Which means that they didn't have to decode subnormals, so it fits into the same bucket of reduced implement. So this is like a partial implementation of floats, I guess.
That sounds bad to me, but
I agree. This was something somebody wanted. There's the thing about 65-bit ints, which may or may not fit in here.
oh yeah.
because I think it may actually.
Yeah.
There's custom simples. So these are, simples that don't have one of the 5 constants in them.
Yep.
And somebody wanted, it's because of DC board, there's undefined. Definitely fits in here.
Yep.
And then -0 is the other one.
-0 float, right?
Correct. There is no -0 int.
Yeah.
Let me see what else I've got on the other side here. I think that's it. I've got, there's this this is a DC board thing, but if I receive a float that's an even integer, need to be able to reject that. But that's not a partial implementation issue.
Yep.
That's a numeric reduction issue.
Yep.
And I think that's it that I've got so far. Was that helpful?
Yeah. Makes sense. I mean, totally makes sense to me. Karsten?
Yeah, I think the non-true false null simples is a good example for something we may not want to do. So if you do something in a standard like this, where you say, oh, by the way, this is on the list of things that we actually don't take so serious as part of our representation format, so many people will ignore it, then many people will ignore it. And we should be careful in what normative statements we want to make here, even if they may not be entirely normative the way we phrase them, but they are normative in practice then. So
Okay.
simple is the one that actually I would not be so happy with putting in the basket of things that you can leave out.
Okay. So let me go back to my, so that's really useful, and I will definitely add some text about partial implementations and do some rewording about the non-interoperable, the stuff I say about non-interoperable. So this was super useful. I just want to go back into the last bullets on the slide and check in with that. So the point there is, the third bullet there is, most use is not in a constrained environment. So a common serialization is practical and highly beneficial. So that's the motivation behind Preferred Plus. Also, it works out great that Preferred Plus is deterministic, except you just need to add, except for maps. So to me, this is a pretty sweet spot, and it lines up really great with RFC 8949 preferred serialization and 8949 4.2.1. Karsten?
Yeah, I'm not so happy with doing something that has a certain property except when. Because people are going to build their security around this property and will be surprised when the except when actually hits them. So all the examples I actually looked at actually benefit from calling them out as deterministic. And yeah, when you do a partial implementation, you might croak on a map because you don't know how to handle that. But that's a decision that a deterministic user of deterministic encoding can make as a data model to help partial implementations.
Okay, I did not follow that. My comments here are about serialization, not whether you support maps or not. I mean, I'm still trying to keep that orthogonal serialization. You know, if you support maps, then you do it this way. If you support floats, then you do it this way. So partial is, you know, has two axes. Are you like disagreeing with what the choices are for preferred plus? Preferred plus is a
No.
serialization.
Well, preferred plus is way more than a serialization, but we can discuss that at a different time. What is important to me right now is something, a selection, a choice that a protocol developer could sensibly make that is deterministic except for. That's really bad design. We should not do that. We should not say preferred is deterministic except. That's not a property that protocol designers and implementers should rely on.
Okay, but I mean,
So
I have my
you just set it the other direction.
yeah. Okay.
Say in order to get a deterministic encoding, you do preferred plus and add these three other things or this one other thing, whatever.
Yeah. Well, it's one other thing, and it's map sorting, and the text in the document is that way. This is just the way I wrote the bullet, which is
Yeah, I was specifically reacting to what the sentence on the slide says.
okay.
And
All
I
right.
don't know whether it's actually in the text, but this
It's not.
poor man's deterministic encoding. This is just sitting there and waiting to bite us.
I mean, the document says preferred plus is this, and this, and then it says deterministic is preferred plus with maps sorted. That's all. So okay.
Okay, so this is actually something I have a slide for. How many slides do you still have? Oh, 4 more. Okay, let's do that later.
Yeah. Okay. So I'm not hearing any change to the sort of normative definitions of preferred plus and deterministic serialization. Am I hearing that correct? I mean, that preferred plus is well, actually, the question I have, Karsten, you said preferred plus is way more than serialization. I would agree that it's slightly more than serialization, but what's the difference between my view that it's slightly and your view that it's way more?
Well, it violates the orthogonality between serialization and data model restrictions. So something that is as central to our considerations as this set of serialization constraints probably shouldn't have that drawback.
Joe?
Yeah, so I think we've got a way forward on that. So let's see what happens to the doc when we do the partial implementation bit and see if that handles your concern, which it may.
Yeah, I'm not sure about that. At least not what I'm thinking right now. We'll see what happens when I try. But I wouldn't. I mean, I don't think that's way more. Yeah, I agree that what is described as preferred plus is not strictly serialization. The variations, there are NAND payloads and the tags 2 and 3. And I think that in a detailed discussion here, it's worth being aware of that. In the real world, where people are just writing code and sending data back and forth, I don't think it matters. And I think trying to drive that distinction in the real world is going to be detrimental. We don't want to drag the real world, most of the people, into this messy discussions we have here. That's the view I'm taking on that. I think Rohan would agree with that too. Okay. So the other slides I have are on another topic, on the test vectors.
Okay, so then let's pop over to Karsten's issue and then
Okay.
come back to the test vectors.
Yeah.
Okay, Karsten, I'm going to give you slide foo here.
Thank you.
Okay.
Okay, so I think we already went through part of the partial implementation discussion, so I don't have to repeat that here. But again, we are doing partial implementations. We are discussing partial implementations because we want to facilitate less expensive implementation approaches when some functionality of the specification is not needed. And the prerequisite for that is that encoder and decoder need to agree on something. And what that something is, I think, is the interesting discussion. Now, I'm going to try to use some terminology here that we have been using before, where we have an encoder and a decoder that are really the CBOR things, and we have applications that also may have data model implications, but are different from the encoder and the decoder. Anyway, so there is a very interesting start of section 4.3, which says when to use preferred plus serialization. The purpose of preferred plus serialization is to provide interoperability without requiring support for indefinite length decoding. If an encoder never produces indefinite length items, it will work. That's the rest of the section say. So I'm really happy about clearly identifying this, because the preferred serialization really is a red herring here. It's not the part that is interesting. It's interesting to give the decoder license to not implement indefinite length decoding. And that leads to an interoperability constraint. So the encoder is suddenly bound when you opt for definite length only. The encoder is suddenly bound to use definite length only, which fortunately is absolutely trivial to implement. So it's really hard to get wrong. And the decoder can rely on this, so it can simply not implement that part, error out on the seeing indefinite length encoding. So in this situation, when there is an opt-in on DLO, we have full interoperability, and we don't have any sudden weird things happening. Now, there is something different going on here with preferred serialization. First of all, preferred serialization is good. I think we all agree about that, and we probably also wouldn't write a JSON implementation that writes 7.00. But yeah, so for a CBOR encoder, it's good implementation practice to generate preferred serialization. But knowing that preferred serialization is in use does not mean that the CBOR decoder has some benefit from that, because it already contains code to handle all those variations depending on the actual data. So you cannot save code by saying, I'm only allowing 2-byte arguments when the numbers between 17 and 95. That is not something that simplifies the decoder. So I would say I have asked this question a lot, and the non-answers I have gotten sound a lot like there are simply no gains in the decoder from prescribing preferred serialization. And I made my poor man's determinism argument already, so I'm not going to make it again. So when we talk about partial implementations in preferred serialization, there is no benefit from a partial implementation in a decoder. There is a benefit in the encoder, which Joe just said on the chat. The encoder can benefit from not doing some work that preferred serialization requires them to do. So you would always send binary 64 if that's what your implementation wants. Or always send binary 32 if you are a constrained environment on the Cortex M4 processor with a floating point option. The decoder already has to decode valid CBOR anyway, so there's nothing gained. Not for serialization. For data model, sure. Not for serialization. So what I'm trying to say here is that we do not need an interoperability constraint that is based on preferred serialization. And I think that's really important. We do need an interoperability constraint as soon as we actually want determinism. And we have a different serialization constraint for that. So that is composed of the definite length only constraint, of the preferred serialization constraint, and plus a few things we can discuss. And on lexicographic map ordering, or for legacy, on the length first map ordering. But there is no benefit from having a partial implementation here. And actually, in many cases, we are never decoding the deterministic part, but that's just some whipped cream on top. Okay, so let me say why I think this is important. Outside of deterministic encoding, and that's even why I set out writing out a document about deterministic encoding, and preferred serialization came in there because it's needed for deterministic encoding. But outside deterministic encoding, preferred serialization is useful for encoding quality. It's a unilateral decision of the encoder to do that. And moving this into an interoperability constraint will, and I'm saying this with a lot of confidence, misguide decoders into rejecting valid CBOR. And section 4.2 actually seems to be designed to do that, while other parts of the document are not so clear about that. So I'm not sure that the document currently is internally consistent here. So I'm saying this because I know that partial implementations of preferred serialization on the encoder side are out there, and they are not going to go away next week. So I think what we need to do at some point is do this work on interoperability. For instance, Joe's test vector project, which I think is developing really nicely. And that should be our way to help the community, not by making available names for normative decisions that create interoperability problems. And that's all I wanted to say about my slides.
Discussion? Or is it just time to go back to Lawrence?
Yeah, I don't. I'm not sure where to go with all that. I mean, I wrote some comments in the chat, but it seems to me you can create serialization interoperability problems in lots of different ways. It's not just definite and indefinite lengths, and I think there is a large benefit for the decoder to not implement some parts of the serialization. You know, indefinite lengths are indefinite lengths are definitely a burden to the decoder. That's for sure. So
Michael, can you say that with your mouth? Or
I think so. Can I say that with my mouth? Yeah. What I heard from this is that it's good to have decoders that are enforcing where what the protocol, the higher protocol, wanted in its specific serialization, and that doing so means that we catch implementation bugs in other encoders or other things like this. And so that's good for keeping the kind of extend part of embrace afterwards from happening. But it's bad because it potentially stifles future activity or well, I think that's the point, right? Yeah.
Yeah, that's not what I said. Yeah, so what Vadim says, that's really the nightmare. So if you put something into the ecosystem that is optionally enforced, you divide the ecosystem into two halves, one that works and one that doesn't. And for no good reason. Basically, decoders that enforce preferred serialization without really needing deterministic serialization, those are the source of interoperability problems. You should not do that. And I'm not sure what you mean by future evolution, because this is about today and how probably implementations will be for a long time in the future.
Well, if we had a set of things that, and everybody is in codes with the same, I'm going to say subset for lack of the right terms from Lawrence's document, if that's not the correct thing, then should there be a point where the protocol wants to evolve and change its change the serialization it has selected. I want to say it's preferred serialization. Then we can't do that because those other decoders will be intolerant of that, right? Other than that, I'm not seeing what the effect of those limited decoders are. As you say, you can split the ecosystem, yes, but then weren't some of the encoders violating some spec to begin with if they were used going beyond that selected serialization? Like I told you not to use floats and I don't want any nans, and then you decided to encode them by mistake because you didn't even notice with your full size encoder. And you worked fine because other people were full decoding it. The 7.00 problem, essentially, that no one necessarily sees until they see it.
Yeah, so I'm reminded of a problem I had, which is not exactly the same problem, but it's the same class of problem. So I ran into a JSON library that implements decimal points, but not exponents. And that's exactly the kind of problem
Yeah,
that I would like to avoid.
I agree with you. That is a really annoying thing, and the implement for whoever did that needs a big stick with which they can be hit over the head that says you either do all of it or none of it or something, right? But in the context of we are not using floating point at all, that problem is not as irrelevant, right? It's just that it could be that it could be that somebody was getting away with throwing in decimal points, maybe with trailing zeros, and nobody noticed that. And that's why I think I agree that we need better test vectors than that. We need to do other things. So, I mean, I hear what you're saying about you could be creating interoperability problems for no point, but I think that was the point of having the CBOR protocol user define what they're doing. And my impression, again, I said this on the list and I got disagreement, was that the purpose of naming these things is so that when I go to pick my library or compiler to pick the options of it, that I am consistently getting what is expected. Whereas if I have to toggle, 12 options on and on, the ninth of them I might get wrong or miss, and therefore emit 16-bit floats when I should never do that, right? And I didn't notice until it happened, right?
Okay, so this whole flow of discussion and concept is out of order for me. So I do not believe we solve this problem by getting libraries to behave. The reason that there's a whole bunch of text about end-to-end protocols and framework protocols and stuff is in there is to sort of understand, to frame this in terms of standards definition. So the major point here is that when you're writing a standard for a CBOR-based protocol, you have to, particularly an end-to-end protocol, you have to specify the serialization. You have to be precise, clear, and complete about the specification of the serialization. You can't rely on libraries and stuff like that. That's not right. It's not what I don't think that's what we do in the IETF. If you look at some protocols that are CBOR based, you can see that they are going out to the trouble of specifying their serialization. So, for example, CTAP and that file system protocol, and there was another one I turned up. They all go to some trouble to write out what the serialization requirements for their protocol are. So the point of Preferred Plus is that for most protocol definitions, they can say this protocol, this end-to-end protocol in this implementation uses Preferred Plus. Then it's up to the implementers to find libraries to do what they need to do. And like if that protocol doesn't use float, then they can find out a library that doesn't support float, and they will find out very, very quickly if their library doesn't support the data types they need. So I I mean, I find the whole discussion about interoperability being solved for protocols via testing and libraries and in convincing library implementers to do things and stuff like that. I find that all backwards. I mean, I'm fairly serious, fairly opinionated about that.
Okay, we are getting close to out of time now. I just want to spend a couple of minutes talking about the agenda for 125. So I propose that we defer the test vector strategy discussion to the 125 session because we don't have time for it now. Does that work?
Yes.
Okay. Good. So, well, yeah, and as Carsten says, take it to the list too. So we have continued discussion on the list, and we will meet again in a couple of weeks. What we have right now with the agenda is pretty straightforward. Basically, it's going to be continuing discussion of the issues in the serialization documents, see where we are there. And we've just sort of sketched out the bulk of the meeting, 60 minutes for that, and then we'll talk about the test vector strategy. I think given our goal here of wrapping up the serialization, I'm not inclined to put other things on the agenda. But if somebody has something they would really like to see on the agenda as well, let me know now. You can also post it to the list, but are we good with this agenda? We don't have a thumbs up thing here, but if anybody objects to this agenda, let me know. Carsten.
I think we really should be moving forward with CBOR Pact and EDN at this point, because we know that this document will take a while, and there is no point in making the other work impossible while that happens.
Okay, I'm going to put on the agenda well, there is already an agenda of the explanation of the focus of the working group. There's 10 minutes for intro administration and that's probably enough. Let's discuss that at the 125 session, at the beginning of the 125 session when Paul is also in the room. And we'll see where that takes us.
Yeah, so essentially what we need there are working group last calls and or processing of working group last calls. And so the chairs will be involved with that.
Okay. So that will be part of it. Let me, let's put this in. What about other documents? I should say the other documents. Okay. That will be early on the agenda. We will discuss the status of that. Yeah, it may be that serialization is far enough along that we can do that. Let's see what we think collectively. Okay, I think we are done for today. It is less than a minute before the top of the hour. Does anyone have a final word they want to put in before we wrap it up?
Yeah, I'm gonna try. I mean, I know it's not maybe correct protocol, but I'll try to get a new version of the draft out with the partial implementation stuff and with my initial version of the test vector plan. Just so we have something to
I think it is absolutely the right thing to put out an update as soon as the moratorium lifts. So do it.
Yeah. Okay. When does that lift?
I believe it's Monday morning. And actually, if you have something sooner, if you want to post something sooner, we can do a manual post. We can get approval from me through the area, from Andy through me or whatever.
Yeah, and they'll show up as PRs before that too. So
yeah. So if you post something next week, it'll show up as held, and we'll get it unheld.
Okay.
Okay. Thanks, everybody, and we'll see you in less than 2 weeks.
Thank you.